And then I'm going to minimize that and maximize that. All right, let me make sure that works. So as Jim said, I'm Steve Mayzak from ElasticSearch. I've been with Elasticsearch for about a year now. Prior to that, I was at a company called SpringSource, the company behind the Spring Framework, who got acquired by VMware and has now spun out into Pivotal. But I'm here now, and I live in Portland, but I travel all over, and we have a team now of sales engineers at Elasticsearch all over the world. And we've grown from 40 people when I joined to over 100 now. And, we're hiring like everybody else right now, I think. So we don't hire for location, we hire for talent. Doesn't matter where you live. We have people in Bucharest, Romania, Italy, Spain, Amsterdam, Tennessee, you name it. We have people all over. All right, so Elasticsearch. The open source project started about 4.5 years ago by a guy named Shai Bannon. And Shai has a long history in search technologies. And so we wanted to create a search product or a project that was basically something that was distributed by default, built on top of Lucene, but really simplified the APIs in Lucene because Lucene's kind of complex to use. And he wanted it to be RESTful, so everything that you do in Elasticsearch is via a REST interface. And then he wanted it to be all JSON. So you submit a JSON document in, you get a JSON document back. It takes care of translating that down into Lucene under the covers. Fairly easy, yeah. So about 3 years ago, he had so many support requests for help with Elasticsearch that he decided to get a bunch of people together and start a company. There was no plan to go public or get acquired. It was just, we need to help support people using Elasticsearch. He wanted everyone to be successful with it. And that's why we have a company today. And so we actually sell a support subscription for Elasticsearch. So it's all open source with few exceptions. And we sell support subscriptions, and we now support hundreds of companies using Elasticsearch, but we just passed 10 million, or we're almost to 11 million downloads now in the last 2 years. So we have no idea who's using Elasticsearch. People come out of the woodwork every day. We find out via Twitter, customers calling us, just everywhere. It's everywhere.
How does the data size of your customer population break down? Like, what percentage is over a terabyte or petabyte?
I don't have that data just yet. I do. We are doing some dog fooding. I'll talk about that later. So remind me to ask me again when I show Marvel, and I can talk about some of the stats we're collecting. Yeah. We also offer training, and we do our training. It's focused on developers and operations folks. So we do public training. We just had one in Seattle a few months ago. We do one in San Francisco every month because we have an office down there, and we do them all over the world. And we also do an ELK workshop. So ELK stands for Elasticsearch, Logstash, and Kibana, and I'll get to those. But the workshop basically helps you understand how to build an ELK stack to do logging analytics. And we drive these projects forward. So we hired the lead developers and the committers on Logstash and Kibana. So they now have teams in Elasticsearch working on those two things. And of course, we have all the Elasticsearch committers, or most of them. And we now have product managers that are trying to create an integrated stack so everything works really well together, as well as some other things to come. And we do have a commercial product called Marvel. And Marvel is the monitoring and management interface for Elasticsearch. So the nice thing about Marvel is it uses all the REST APIs that are already there to get data. So eventually you'll be able to just push button to add a new node or something like that. Right now it's just showing metrics and things like that. But it has some cool interfaces I'll show you guys as we go through.
Is it JMX based?
No, we're actually trying to get rid of JMX in the code base. It's all REST. No, there's a bunch of open source alternatives like Big Desk, Head. There's one called, I can't remember the other one, Elastic HQ or something like that. So Elasticsearch supports this idea of a site plugin. So you can build a plugin that's just HTML and JavaScript, and Elasticsearch will host it for you. So you can just make a request to a special port, and then in the HTML5 application, it makes the REST calls back and forth. So it runs in the Elasticsearch process. And then we're backed by some, what I think are pretty good VCs, actually. Benchmark, Peter Fenton, Index Ventures, Mike Volpe, and then NEA, Harry Weller. That's our funding. So who's using us? I mentioned everybody's using us. It's open source. It's really hard to tell, but these are some of the companies that we support, have come out and done meetups with us, like this one. A lot of companies in the Bay Area host meetups, and we try to record them as much as we can. So if you go onto our website, we list all of them, and if there's a recording, it'll be there. So there's some really good ones from Thomson Reuters, from Bloomberg, from Netflix. The Facebook one was recorded. We just did one with HipChat. Lots and lots of good companies. So, and here's just the kind of how our customers work with us, the different support subscriptions. So I'll get through the commercial really quickly. So there's Silver, Gold, Platinum. That's basically, pick up the phone if you need help if something goes wrong. But it also includes development support, which is more like getting help from some remote consultant than just being able to pick up the phone and ask for help at 2 a.m. So if you need help designing your document structure, figuring out how to write the queries, how to write the Kibana dashboards, how to tune and grow your cluster, that's what we're for. Yeah. And then Marvel, I'll show you guys a demo of this later, so I don't need to spend any time on this one. All right, so Elasticsearch is it's a distributed and scalable search engine built on top of Lucene. Are everyone familiar with Lucene? Heads nodding. For those of you that aren't, it's an information retrieval library written in Java. It's actually created by a guy named Doug Cutting about 15 years ago, the same guy that created Hadoop. It's hiding all the complexity of Lucene behind the scenes in a JSON API. So Shai, when he first started, and now this is kind of one of the core tenets of the company, is developer empathy. We want to make sure that the developer experience is really, really easy because we're developers. My background's in development. We're an engineering-led company. If it's hard to use, it's a bug. And so everything we do tries to be consistent with that API, make it easy to use. And in that sense, we have a bunch of clients that you can use with Elasticsearch. So if you don't want to code all the rest yourself, we have .NET, Java, PHP, Perl, Python, Ruby. There's a Go client, a bunch. Any languages in here that people use that I didn't mention? There's even a Scala one. JavaScript. Oh, yeah, there's a JavaScript. Yeah. I use that one actually personally because it runs in Node.js. It's really simple. Yeah. So it has replication, failover, load balancing. All those things are built in. So a lot of people ask me if it runs on top of HDFS. It does not. It just uses local disk because it will replicate your data just like HDFS would without the performance hit. And it is super, super fast. So some of the use cases for Elasticsearch are very far reaching. I talked to a customer a few months ago that replaced Oracle Coherence with it because it's just so fast and they were just using it for a cache. It's not to say it's an in-memory data grid. It's not. But if you're just using something for a fast cache, it's great. You get responses in milliseconds. Doesn't matter if you have 100,000 documents in there or 500 billion. You'll get these responses back very quickly. And it's a search engine, not a search tool in a box. So it's not SharePoint. It's not a off-the-shelf thing that you can just install and it has a UI, right? It's a developer tool. There is a UI called Kibana, which we'll show later, but it's not going to replace some Google search appliance. That's not what it's for. By the way, if you guys have questions throughout, just jump in and ask. No need to wait until the end. So in Elasticsearch, you start out with a node. A node is a single instance of the Java process. It's all written in Java. So you start that up on your command line and it's all of a sudden running Elasticsearch. You go to your browser, you type in localhost 9200, and it gives you a JSON response saying I'm available. And then when you add another node, it'll join that other node, the first node, and create a cluster. So out of the box, it uses multicast. It will find the other Elasticsearch nodes, and it will create a cluster. If there's more than one, it will elect a master. And as it grows, it'll elect more and more masters, and it will manage the cluster itself. Now, like anything, there's best practices for when you're going from development to production. So it's important not to go to production with the defaults. You have to lock it down just like anything. In Elasticsearch, a cluster manages multiple indices. So an index, think of an index like a database in the database world. So you could think of an index as a database. In the index, there's types. Types would be synonymous with tables. And then inside the types, there's documents, and that would be a row in a database. That's the easiest way to kind of map it in your head. And a cluster will manage itself. So like any good distributed system, if a node dies and you have replicated data, it will start replicating the data somewhere else because a node just died and it wants to make sure your data is available. The cluster has various states. It's very simple. Actually, it's red, yellow, or green. Red means that all your data is not available. Something's bad has happened and there's too many nodes offline and I can't turn them back on. Yellow means that all your data is available, but it's not meeting your replication policy, which means there's not enough nodes to replicate to. You'll notice when you start your first instance of Elasticsearch and you put data in, the cluster state will be yellow because you don't have another node to replicate to. And the default policy is one replica. And then, oh, go ahead.
graphics in your rows, and what kind of
JSON data. So you can store binary data in there, but it's not good for binary data. Yeah. Like, all the major types, string, date, any number. We support geos out of the box. Yeah.
no blobs or objects?
You can do it, but Elasticsearch wasn't designed for that. So I'd store that somewhere else. Yeah. So I thought it'd be cool to kind of walk through an example of a JSON doc because we support structured and unstructured data, and later I'll show you a demo of why this is important. But the idea is that this is just any random JSON document. It's got all types of data in here. It's got some strings, some numbers, free text, some terms, and then some geo. And all this data you can use in Elasticsearch in different ways. So when I get to the Kibana demo, I'll walk through some more of that. So here's how people are using Elasticsearch. We have customers that are looking at all of their logs. It could be gigabytes a day, it could be terabytes a day. Some companies are even scaling up to the petabytes a day, and they want to find out things like, am I a victim of a DDoS attack right now? What searches are trending on my website? Companies like, or not companies, but Wikipedia, the English version is powered by Elasticsearch. When you go to any WordPress blog and you do a search, that's Elasticsearch. So you can see things like that. A lot of people want to understand where their customers are coming from. So there's a company over in the UK called The Guardian. It's a newspaper. They built this entire application on Elasticsearch that shows all the content producers, the editors, where their audience is coming from, whether it's Facebook, Twitter, Drudge Report, and what the profile of those customers are based on the data they have. And it allows them to create content and see if it hits the mark or misses the mark based on the target they're trying to go after. It's very popular in e-commerce. So there's a couple e-commerce as a service vendors over in Europe that are using it. Most of the e-commerce companies that we support aren't allowed to mention their names, but a lot of e-commerce companies, when you go on and you do a search, you're using Elasticsearch. And they also use Elasticsearch not just for search, but for powering the experience behind the search. So when you're on a website and you add something to your cart, that event gets captured via JavaScript. It sends it, sometimes you guys might be used to using Google Analytics or something. Well, you can send that event into Elasticsearch and build a dashboard just like that so that business users can see exactly what's happening on their website in real time rather than having to wait for some Hadoop job 2 weeks later to say, oh, that campaign that we ran sucked. Well, we could have known that right when it was happening and make changes on the fly rather than having to wait.
Good question on that. So the dashboard itself, representation of the dashboard, that visual representation is a result of a massive number of ongoing searches, or is it just a representation of the index itself?
It's a representation of the results of a search,
Okay, so
but it will auto refresh for you.
Right. So
Yeah.
you've got multiple searches going on in the background.
Yeah. Yeah.
Really familiar with Splunk, so I'm
Yep. Yeah, exactly. So one of the main differences between us and Splunk, there are a lot, is that we're more of a general purpose analytics tool. So people use us for web logs, but they also use us to power search experiences, human generated data. And we will never be all that Splunk is because they're going after a specific audience. And they don't do indexing as documents come in. They do indexing as the documents are searched. So what does the analytics stack look like? Well, this is Kibana. This is some screenshots. You can see a bunch of different visualizations. And the funny thing is, on Monday, this is all obsolete because we're releasing the new version of Kibana, which is orders of magnitude better than this. And this is pretty dang good. So we're releasing a beta of Kibana 4. Monday is the plan. And I'll talk about some of the reasons why we're doing that in a little bit. So Logstash, how many of you are familiar with Logstash? A few? So Logstash is the log collector aggregator that people use with the ELK stack. It's the L in the ELK stack. And what it does is it collects logs, collects things from a socket, can collect data from a router, and it will bring that data in and then it will parse it, process it via a series of under the covers regular expression patterns that we've pre-built for everybody. And it will take a Apache log and separate it out into the various different fields like the status code, the resource that was requested, IP address. It can even do some enrichment. It comes shipped with a GeoIP mapping database. And then it will convert that data into JSON and send it over to Elasticsearch for indexing.
So JSON's it, right? I mean, that's all you're getting, basically modified XML, and that's your schema, that's it.
Yep.
So it's got to come to you as JSON. No other way.
Yeah, I mean, you could have a JSON document that has one field and one value, and the value can be whatever you want. It could be HTML, it could be XML, but the overall structure, the wrapping structure is JSON. Yeah.
So should I think of Logstash as something that goes out and crawls the data sources?
No, it's more of like a client that you would run on a machine that grabs or tails log files, or opens up a socket and listens for events. And then once it gets to Logstash, it processes it and sends it to Elasticsearch. It doesn't do web crawling.
So my logging infrastructure would really have to have some Logstash process running all the time to collect my log files.
Yes, there's a lighter weight version of Logstash. It's called the Logstash Forwarder. It's written in Go, so you can install it anywhere you can run Go. And it simply tails a log file and sends it to wherever you want, whether it's Logstash or a message queue. And I'll get into some of the architecture stuff later. But a lot of people use like rsyslog, some other logging aggregation mechanism they have today, and then they'll put Logstash wherever all those logs are collected. So you don't have to have thousands of Logstashes. You can have tens or hundreds, and then thousands of servers.
And Logstash must be able to communicate to that Elasticsearch instance.
Yep. Yeah. Well, not necessarily. I'll get into that too. Yeah.
Logstash, is it only for file systems, or can you actually connect it to a database where you store the log messages?
Yes, but if you want to connect it to a data store other than, well, database, traditional database other than SimpleDB, you have to write a connector. So Logstash has this idea of inputs, filters, and outputs. And inputs, we have like 20 or 30 inputs on the website. So there's file, email, there's one for Gemfire, one for RabbitMQ. We're coming out with one for Kafka. These are all the sources you can consume data from. And then there's a bunch of codecs. You can convert it to CSV, XML, JSON. And then there's a bunch of outputs. And the outputs typically mirror the inputs, but it's not necessarily the case. You can even consume data from one Elasticsearch cluster and send it to another one if you wanted to, using Logstash. Yeah. So we have connectors, so we have connectors for CouchDB that they wrote. There's one out there in the open source community for Mongo, and a bunch of people have written their own little thing for traditional relational databases. The reason we don't have one for relational databases is because you have to flatten out your relational structure to put it into Elasticsearch. There's only two types of relationships. There's nested documents and parent-child. So we're not going to support a bunch of foreign keys. You need to flatten that out before you put it in. So it's hard to build one that's generic for everybody. Yeah. Yes, so there's like tools like Talend or Pentaho has one. People use those.
Everything in front of you basically is a form of ETL anyway.
Yeah. Yeah. There's lots of ways to do it. Yeah. Question? Yeah, Eugene.
Log files may have different formats.
Yes.
How Logstash know about this whole variety of formats?
So there's a series of patterns, regex patterns, that we've written already for you. There's like 80 of them. And what you do is you basically chain them together by name. So this one would be called IP address. This one would be called timestamp for the formats of logs that you're trying to parse. This is another difference between Splunk. In Splunk, it just grabs the data. And this is why it doesn't index on the way in. What we're doing with Elasticsearch is we're processing and formatting or structuring the data on the way in. So in Logstash, you're going to have a series of configs, one for Apache, one for Tomcat, one for a router, one for WebSphere, one for IIS, because of all the different log file formats. But you can keep a master config and then just copy it to all the machines. And what you do is at the end of the day, you'll have this config that says, here's the IP address, here's the timestamp, here's the status code, here's the requested resource. But yeah, but it's really simple. You just put one word, and then under the covers, it knows what to do. It's very simple. And there's a tutorial on the Logstash website. If you go to logstash.net and you go to docs, there's a getting started guide. And in 45 minutes, you'll be parsing Apache weblogs, and all you'll have typed is just this little config file. It's pretty impressive.
You can say, you actually have no schema. And Splunk says, oh, we have no schema either, but they do. They have a timestamp times their main key.
Yep.
Then they have a host name, host source, I think, data source, and those are keys for schema.
Yeah.
And you can establish any schema you want, right?
Yep.
You're not limited in any way.
exactly. You don't have to put time series data in Elasticsearch.
Well, but implicitly, you're defining a schema by defining the normalization, right? Because certainly if you're defining the fields that you want to put it into.
Yeah, programmatically you are. But in Elasticsearch, there's no need to go in and create a schema, and then when you want to do an upgrade, you have to, use like a DML script or anything like that. That doesn't exist.
So it would be too much at some point in the future if a different log file contains other data, then you can easily tie that in, and that automatically will create new fields in your Elasticsearch instance, essentially.
Yeah, so if your log file format changes, you do have to make a change in the Logstash config to pick up the new change. But until then, Logstash will tell you that there's a new change because it'll put a special tag in the message saying that there was a failure, a parsing failure, but it will still parse what it can. Yeah. No, it's fine. I have till midnight.
Yeah, I'm just thinking of something in terms of, okay, so I've got this flexibility for the schema in my indices. Right?
Yeah.
So I can take the same data, and sometimes it can be very long strings of stuff, right? And parse it a certain way for one index where I'm looking for a specific thing, and maybe it's a speed-oriented thing, and then parse it another way for another index to look for different things in that same
Yep.
data.
Yeah.
And I could probably do that with as many ways as I have indices.
You can have as many indexes as you want. There's no limit. Yeah. Yeah, you can even parse the same field multiple times in the same document. So, for example, you could say that, let's say you have a paragraph of text and you want to parse that paragraph term by term. So you would say index it once, just separating the words on white space, index it again in another field called field 2, and it's indexed every single character so that when you're doing autocomplete, it will grab that back. You can even do it like just the prefix, the first 3 letters, things like that.
So I'm working with a company that does redaction in documents.
Okay.
So you have a single document, and it gets redacted. So paragraph 1 gets redacted, and then that goes to a SharePoint. Paragraphs 1 and 3 get redacted, and that goes to a different SharePoint. It sounds like you can do actually the same thing by just having different indices. In other words, I can actually create documents based on the data that's in the index, and then just pull it and put it somewhere.
Well, you could have them in the same index, different type. Type 1, type 2, type 3. Think of an index as the database, and then the types as the tables. So you have different types in the same index. Yeah. You have document index basically, doc type 1, doc type 2, doc type 3. Yeah. So the components that make up the ELK stack are Logstash, Elasticsearch, Kibana. Yes, it is LEK, but that was taken by a leak soup. So we used ELK. It's much more recognizable. So why do people choose ELK? I've been here for a year. I've talked to probably hundreds of people that are using ELK, and I didn't make up reasons why they use ELK. They told me. I ask all the time. I even ask companies, why would you use us over Splunk? And they tell me lots of interesting things. So a couple of them are the fact that we were built by developers and operations people for developers and operations people. It's very much right now a DevOps tool, although we're starting to get into more business user web analytics type use cases. But developers are the ones that build those tools for the business people. It's easier to manage and monitor at scale. So I've talked to companies that have massive deployments of things like Splunk, and it was not built for that kind of scale. It's also not priced for that kind of scale, but that's a different story. And Elasticsearch was built so that you can interact with it via an API, and that's how operations folks want to manage their infrastructure. So it was built for that by default.
I'll just keep going. One of the things with Splunk is actually an enterprise-wide upgrade. Gets really ugly really fast.
Yeah.
What about you guys in that regard? You've got, ELK is basically 3 separate packages.
Yes.
3 separate development streams. How do you do that?
Well, so for a company that wants to build any sort of monetary model around open source, part of the value that we bring is integrating the components. That's what we're doing. So, we're in the process of doing that right now. One of our goals is to make everything easier to work with and offer it maybe eventually as one package that you just install for this use case. As far as pricing, we price per node. There's no limit to the data. Yeah, so a lot of open source companies will build an open source version and an enterprise version. We don't do that. It's all free to download right now. Marvel is the only thing that you have to pay for, but that's only in production. It's free for development use, and it comes with a support subscription. So if you want to use Elasticsearch today, there's no charge for it. we make our money by offering awesome support. That's how we make our money, so it has to be awesome. And we will eventually monetize things other than just Marvel, and that stuff's coming. But right now, and we'll never have an enterprise version of Elasticsearch and a commercial or an open source version. It will always be open source. So Elasticsearch to Logstash and Kibana, the ELK stack, is much more flexible in its architecture. You caught onto this right away, which was kind of cool, is that we're way more flexible than things like Splunk because of all the integration points we have. And I haven't even gotten into the fact that we have a Hadoop connector that connects to Hadoop and Spark and Storm. So if you're using these components, you can get data out of those things into Elasticsearch or the other way around. And I'll cover that more when I get to the architecture slides. Total cost of ownership is much lower than the alternatives. And one of my favorites is it doesn't run out of gas. I was told this by a customer because I guess if you use too much of Splunk, it turns off. If you over-index data, you're allowed like a few things, and then you get your hand slapped, and then you get your door shut. You're grounded, basically.
It also takes a thread or a core per logged on user and for search. So if you've got a large user population, you got to have a lot of compute threads just to even play with it.
Yeah, that's a good point. And then bring all your logs. So I've talked to multiple customers that are using something like Splunk, and they can't afford to put all their data in there. So some of them have gone as far as like saying this department gets Splunk for a week, this department gets Splunk for a week, and they just kind of round robin, which is no way to run a business. So Elasticsearch allows you to bring all your logs, and then we hope that we provide good enough support that you would want to get a support subscription from us. All right, so let's talk about some data. So this is an example of a query where we're just doing an aggregation query. Aggregation API is the analytics API. So you can do queries like free text search, like WordPress and Wikipedia, and then you can do analytics for building those dashboards. This is an example of an analytics query. And basically what it says is say, give me the terms and organize them. Give me the country terms and organize them by country. So it's England, Germany, France, Spain, and then you can visualize that like this. And basically under the covers, what we're doing here is term counting at the very simplest form. So if you imagine indexing 1 million documents and every single document represents a line in Apache, and you want to say, how many 404 errors did I get? We're going to count the amount of times that the word or the term 404 showed up and then show you in the results. And then we can visualize it like this. And the reason we can do that in milliseconds is because we're storing it in an index, not in a column store.
So you've got a specific algorithm that creates that index, right? So the index means it's a representation of the real data somewhere.
Yeah, it's just like the index in the back of a book. It's an inverted index. So we say the word or the term 200 showed up 50,000 times. And it showed up 50,000 times in this node, in this node, in this node, and then we'll just do the math real quick and show you that it's 150,000. Yeah, so it's very, very simple. But then you can say, show me things like, give me a date histogram and sort it by year of birth. So this would be how many people were born in 1960, 1961, 1962, and you could chart that like this. So just really simple stuff, but really powerful when you apply it at scale. And then you can even do search within aggregations. So you could say, show me by country, by date of birth, by gender, and how many children they have. This is the type of questions you can ask your data. So one thing to think about when you get started with Elasticsearch is not the normal way of thinking about CRUD databases where you're just putting stuff in and you're going to do a select all or select where primary key is this. You need to think about how you're going to ask the data questions, how you're going to query it. It's fundamentally different than how you'd use any NoSQL store I've worked with and a traditional relational database. All right, so let's talk about architecture. The easiest way to get started is just download it from the website and go and unpack it, go into the bin directory and type Elasticsearch. It'll start the node, you have a node. And then you can do this, and this is an example of the response you would get. And one interesting fun fact is that it picks a random name from a list of like 3,000 Marvel characters, because Shai is a fan of comic books. So whenever you start a node, it will just pick a random name unless you give it a name. I actually started one up and it was called Black Death or something like that. Kind of funny. Yeah, so make sure you give it a name. Also, if you guys were all to download Elasticsearch onto your laptops right now and you started it, you would all join each other's, you'd form one big cluster. So the way to avoid that is change the cluster name. So just make sure that's something that you guys do. Otherwise, you'll all...
You say the default cluster name is the same
Default cluster name is Elasticsearch. Yeah. And then you would build an application and just do REST over HTTP. As you scale out, just add more nodes. The problem with this is your app then needs to know which node to talk to, right? Now in Elasticsearch, if you make a request on this node and the data's in this node, it will automatically reroute that request for you and then return back. But that doesn't really scale because then all your requests are going to one single node. So you need to load balance. And we built all these clients to have load balancing built in. So you would give this thing the IP address list of all the nodes you have, and it will round robin between all of them for you. That's a simple way to do it, but there's an even better way, which is to add, let me get to node types. So by default, when you start Elasticsearch, there's 4 different node types that you can be, and it starts out with 3 of them by default. So there's client node, data node, and master node. So when I start one node, it's all 3 of those. But when you start adding more and more nodes to your cluster and getting to any sort of scale, it makes sense to start having specialized roles. So if you have this, you'd have these client nodes that will store node data, but they'll be load balancers for your cluster. So you can have these Elasticsearch nodes run on some server somewhere. You could even embed one in your app or put it on the same machine as your app. It's just going to be a lightweight Java process that then joins the cluster and starts load balancing your requests. And then over here, you have data node that stores data, and then master nodes make sense to dedicate master nodes so they can take care of the consensus algorithm and keep the cluster state healthy. And then there's another one called the tribe node, which does federated search. So if you have a cluster here, a cluster in Phoenix, a cluster in Tokyo, a cluster in London, you set up one tribe node and you can search all of them at the same time. Oh, so that's basically like a search architecture where you build your app, you use one of the clients, you talk to the Elasticsearch cluster. All the prettiness and all the logic is in your application other than the search stuff. Now for logging analytics, typically what you'll, oh, go ahead.
So you mentioned that the cluster always manages itself. So like if nodes fail, then like client node, for example, goes kaboom, and then some other node would take over that role, or just all of a sudden I don't have enough nodes to fill all these roles.
Yeah, it'll
kind of algorithm in Elasticsearch that does this management.
There's like a Paxos-like consensus algorithm for figuring out master election and stuff like that. But other stuff is more kind of distributed systems, partitions, and how partition tolerance happens and things like that. So it's not going to start another node. That's an infrastructure as a service layer type thing. But what it will do is, let's say you have, in Elasticsearch, when you create an index, it creates a number of shards under the covers. These are partitions. And by default, it's 5. And that is not the right number for you guys. That's just the default. It may or may not be the right number at the end of the day. It's something that you need to determine. So there's this primary shard. Just think of it as a primary shard. And then there's a number of replicas. And that's how many copies of that shard to create. So the default is 5 shards, 1 replica. So let's say we have this many nodes. Let's say we have 3 data nodes. They have 5 shards each and 1 replica. That means I have 30 shards between these. And that means there's going to be a primary, replica. They'll be spread out. Elasticsearch does its best to even things out. In that scenario, if this one dies, then all the replicas all the primaries will take note, and all the replicas that were on here, where the primaries lived on here, will say, hey, my primary is gone. I'm going to now be the primary, and I need to create a replica of myself. So it's going to replicate to the opposite machine in this scenario. Now, you can turn that behavior off too, which is really good for rolling upgrades. Like, I'm going to start killing nodes. Don't do anything. I'm upgrading you. When I'm done upgrading you, then you can rebalance if you need to. So that's how it works under the covers. Yeah. And the way...
So I take it that there's some configurability to how the algorithm works, I guess. Like that this whole management of the cluster.
Well, yeah, so you can control a lot with Elasticsearch. I mean, you can control when rebalancing happens. You can control where shards go. There's this thing called allocation zones. So if you're running in Amazon or Azure and you have availability zones, you could say put the primary shards in this one and put the replicas in this one. That way, if there's another power outage on the East Coast, like there seems to be a lot, and that one goes kaboom, then everything on the West Coast is still up and running. And then if St. Helens goes off, Virginia takes over. Yeah.
This also doesn't show data ingestion at all.
That's what I'm getting to right here.
Yeah.
Yeah.
Logstash is somewhere. The
Well, for the search use case, you don't have to use Logstash. And for the logging analytics use case, you may or may not use Logstash. It depends on what you're trying to do. There's lots of ways to get data in. We really don't care how you get data into Elasticsearch. It's a REST API. JSON's the data format. Put it in however you want. People use Flume. They use, you can go direct from Hadoop. You could build a custom app that pulls messages off a queue and sends it into Elasticsearch. Lots of different ways.
Once it goes in, so there's a single node, it becomes the ingestion node.
Nope, that will load balance too. Yeah. So when you think about it for logging analytics or any sort of event database or event data, one of the things you need to think about is how many events you can process per second. And there's a limit for every single node, right? And what I typically say is like 10 to 20 or 10 to 50 or 60,000. This is based on numbers I've heard. Yeah, all that stuff you have to take into consideration. Yeah. But when you do a performance test and you figure out, on your hardware for your use case, how many events you can handle, you just scale from there. I think one of our telco customers is doing 700,000 on 50 nodes or something. Yeah, per second. Practical limits, yes. In theory, there's no limit. Well, yeah, there is a limit, the size of your heap. You can't put anything that's over 32 gigs because we don't recommend going over 32 gigs for your heap. So in reality, it's going to be much smaller. I'm not aware of any hard limit like that. I'm sure there is one. I just don't know what it is. But typically when you're putting docs into Elasticsearch, it's better to have lots of documents with small number of fields than few documents with massive amounts of fields. Yeah. So I wouldn't my default would not be to put a document in that has 1,000 fields. I'd see how I can break those up a little bit if I can. No, I got you. Yeah, the size of the document. But I was just thinking this. No, as the fields grow, the size grows. Yeah. But a lot of stuff like that, you can do bulk loading in Elasticsearch, and you can actually tune how big the bulk is and things like that. So again, lots of tunable parameters here. So for logging analytics, this is how you would start. You'd create one Logstash node or one Logstash instance. It's a JRuby app running on the JVM. And then it can bring in anything. And then that would do the processing, send it to Elasticsearch, and then you would visualize with Kibana. But that's only good for very small setups. As soon as you get to any kind of scale, you need to start scaling this out. So similar to the last thing, we create a cluster, roles get specialized, and then you have Logstash over here. And then over there, you might even have the Logstash forwarder or whatever shipper you have that's custom, doesn't really matter. And then as you grow, another common architecture is to add some sort of broker in here so that you can build back pressure. So if you're an e-commerce company, you run a campaign, or you all of a sudden something goes viral, these things are going to get hammered, and they're going to be able to elastically scale, hopefully, so you can scale up your website. But the logging infrastructure is not going to scale like that. So if you put a broker in here, this thing can handle, millions of events per minute or something like that. And then a lot of people use Kafka because it stores stuff on disk, and you can say replay the last 2 days of data in Kafka, and it will re-index everything. It's really, really powerful. So it's important when you get to a scale. I would say anything over 60, 70,000 events per second, this can start to make sense. And then if you get bigger than that, people start doing this. So they'll have a broker on this side, and then something like Spark or Storm. Spark's becoming pretty popular pretty quick. They'll pull messages off the broker, do some processing and enrichment, send it back to another broker, and then Elasticsearch will pull it off, or Logstash pulls it off and sends it into Elasticsearch. The reason this is becoming popular, part of it is because data enrichment in something like Spark is much more powerful than Logstash. Because let's say you're doing web analytics and you're tracking clicks or the mouse on a web page, and someone adds a product to their cart. The actual event might just have the product ID, but when it gets into the dashboard for the end users inside, product ID is kind of meaningless. So in Spark, you would maybe have cached all the product ID to product name mappings or the colors or something like that. So you do your enrichment there, and then you send it in, and that way in Elasticsearch you can say, show me all the people that are ordering red shoes right now. A message queue. RabbitMQ, Kafka, Redis, yeah. And then you may have Hadoop. This is where you introduce non-real-time stuff. So far we've been talking about a few seconds, like near real-time, almost real-time stuff. Hadoop changes the game, but Hadoop is really good for archival, like really cheap storage at scale. I just want to put a bunch of stuff for 7 years, and I need to keep it for compliance reasons or whatever, then great, throw it in Hadoop. We built a connector called Elasticsearch Hadoop that integrates with Hadoop natively, and you can use Pig, Hive, Cascading, the MapReduce APIs, and then we built in there, even though it's not related to Hadoop, is Storm. So we have Storm integration. So you could completely remove this, the brokers and Logstash, and go direct from Storm into Elasticsearch. And we now have a Spark connector too. So you could go directly from Spark into Elasticsearch. And then from Logstash, you could do like this. You could have Flume sending data to Hadoop, or you could have Flume sending data to Elasticsearch. There's so many different combinations. It's hard to draw that many arrows on a slide. But lots of different ways to get the data in. Flume's like Logstash, but it puts stuff in Hadoop.
Okay.
Yeah. And one thing that and then there's this one too. And I need to draw a new arrow now to show the new integration. But one thing I'm starting to see more and more is that people are using Hadoop to store petabytes. I don't know if there's exabyte clusters yet, whatever, there probably is. It's very common to have my data is bigger than your data kind of conversations. I don't really care how big it is. But what people are doing is they have all this data in Hadoop, and there's been a new focus on data quality rather than just all the data. So I want to take the petabytes and I want to get them down to, a manageable set of like 100 terabytes. But that 100 terabytes is going to be quality data. And then they'll throw that into Elasticsearch, and they'll use Kibana to slice and dice it and figure out what's valuable in there. So people are starting to do this as an exercise to find out, we have all this data, let's find out what's valuable, and then we'll start creating new streams, new workflows that get the valuable data into Elasticsearch by default, rather than having to do the data science 2-week, 1-month delay type of thing.
Are you actually importing the data from GeoSpatial?
Yep. Yeah, it imports it, indexes it, and then it's ready for Kibana. So if you do this is not real time. There's nothing in here that's real time because it's batch oriented.
Where's data quality coming? What, do you have rules or something that ensure data quality?
Well, that's really written into the algorithms here. So it's, data scientists, developers that are figuring out what's crap and what's not.
Right.
Yeah.
So if you import the data into Elasticsearch, doesn't that double the storage cost?
Yep, it does. Yeah, so we've seen customers get rid of, or, they already bought up this huge infrastructure for Hadoop, and they're starting to repurpose some of those machines for Elasticsearch because it makes sense, right? You have a batch-oriented infrastructure, you have real-time oriented infrastructure, and I like to say that we're taking Hadoop the last mile, because once you get Hadoop installed and you put all that data into it, awesome. Now bring your army of programmers to try and add value or extract value out of that data. It's really tough to do that. You have to have someone that knows how to code, and it's not easy, right? I think it's amazing that you can have something like Elasticsearch take Hadoop that last mile and still work with all that. So you get to leverage that investment. Don't throw it away, but use it in a new way. So you still have a smaller subset of the team that's now doing all the data cleansing. It's funny, one of the Cloudera architects called himself a data janitor. It's very true. They are janitors of data. And this way, you actually get value out of that stuff. It doesn't just have to sit there and then you surface it in Excel. I mean, that's not a great experience for the end user. I guess it is if that's what they're used to.
So for that connector, can I actually import subsets of the data?
That's exactly what you would do, yeah. Yeah, you'd write some sort of MapReduce job, and it would spawn off a bunch of, or I don't know, you write some code, right, that would then spin up a bunch of jobs, and it would go process that data, and then the connector is going to take the data from every single node that's running the job, parallelize that into the cluster, into the Elasticsearch. So you can load terabytes of data pretty quickly once the job spins up.
And then subsequently, then instead of writing MapReduce jobs to get information out of the data, you write Elasticsearch queries.
Exactly right. Yeah. You write a query, you do a mouse click on a UI. It says, I just want to see 200 errors. Well, yeah, so that's what Kibana's for. Yeah. Yeah. All right, so before I go, this is the last slide, and then I'm going to go into demo. So before I do that, there's some things I didn't mention. One of them is bulk operations. I did touch on that a little bit, so you can do bulk operations in Elasticsearch. But again, it's not, I wouldn't think of it as some sort of database where you could stream data out of Elasticsearch. There's a reason that Google only shows you 10 results per page, right? Elasticsearch at its core is a search engine, so you don't want to scroll a billion records out of it. That's not what it's designed for. It's designed for answering questions. And if you're doing it for the classic search use case, it will do pagination for you just like a normal search engine should. But I wouldn't set it up to say it's going to be my primary data store and I'm going to stream everything out of it into Hadoop. That's not how it works. I would either split the event into Hadoop and Elasticsearch, or have it go into just Elasticsearch, or have it go into Hadoop and then eventually into Elasticsearch. Say that again?
Well, so there's a local company that has, I think, 400 named Splunk users that are active all the time. So they're constantly doing queries. What you just said is kind of, if my answer has 1,000 hits, or 10,000 hits, or 1 million hits, you're gonna back those up. They're gonna be queued somewhere for me to scroll through. Right?
Yeah, there's a scroll API in there.
If I've got a large number of users, where is that pagination being stored?
It's so there's a scroll API inside of Elasticsearch that stores kind of like the offset, basically.
Is it consumptive?
Yes, it is. Yeah, but I would argue that if you're writing a query that returns 1 million results or 1,000 results, you need to write a better query. Yeah. There's a percolator feature. So because Elasticsearch stores JSON and you communicate to the server in our query language, which is written in JSON, it means you can store the documents, the query documents, in Elasticsearch, and that leads to some interesting use cases. So the percolator allows you to do what we call search and reverse. You would store a document in the percolator, a query document. Like let's say you did one of the queries I showed earlier, right? Show me every country by name or something like that. And then what you would do is you'd submit a document to the percolator. It would run the queries that you've stored in the percolator on that document and tell you which queries matched. So people use this for alerting and classification a lot. So one of the use cases I worked on was a bank that had all these applications from companies. They did loans for businesses. And the process is someone gets on the phone and talks to someone at the business and writes all these notes about that business. And what they wanted to do was figure out, based on searches, what industry those businesses were in. Was it energy? Was it finance? Was it healthcare? And based on the person typing in the data, they would type words like oil, gas, water, energy, kilowatts, whatever. And the queries were written in such a way that when you submit the document to the percolator, it said this is an energy company and it's oil and gas based on the query. So it's really, really powerful.
I see Elasticsearch as this, huge data repository. You're talking about kind of a subset application where
it's a post. It's an HTTP post to Elasticsearch to a special index called the percolator. Yep. Yeah. And then the other thing is people use it for alerts. Like if you submit every event to it and you have a query in there that says, if the response code was 500 or something like that, then you know that there's a 500 error and you can raise an alert, like send something to PagerDuty or email someone, wake somebody up.
Maybe this is about one that goes back to that writing thing. I can submit a document, the percolator can actually take out 2 or 3 sentences of that document and return back to me that entire document.
It won't modify the document. It just runs the query on the queries on the document and tells you which queries matched. So it's better to think of it like, what was the term in the Enron thing where they were using?
I asked it for everything but those three sentences.
Yeah, but you'd have to write those 3 sentences exactly. Yeah. It's better to think of it like, let's say there's some sort of secret thing going on inside of a company and these emails are going back and forth and there's a code word. You'd write a percolator that looks for that code word and then you'd submit all the emails to it and it would tell you which one's matched. Yeah.
So, but if you want to index those documents, you have to send them to the percolator in addition to...
Yes. Yeah. It doesn't index and percolate at the same time. Yeah. So it's meant to kind of do the percolator, get the response back, and then make a decision about what you're going to do with that document. And if you do the classification use case, you might want to say, well, this is now an energy company, so I'm going to put it in the energy type rather than the insurance type, or set a field or something like that.
So you would have to communicate that back as part of the percolator?
Yeah, it'd be 2 requests. You'd make a request to the percolator, get the response, decide what, based on the response, decide what to do next. If it's to index the document, you'd make another request.
Okay, so and then you would update the request that you're sending to ElasticSearch with the percolator's response of the document type.
Yeah, you could do whatever you want in code. Yeah, yeah. Another one is the suggester. So there's a suggester API, just like you're used to with searching on the web. Did you mean this rather than that? You can do index aliases. This is really powerful. So one of the things that people get into right away is they see the number of shards in an index is finite. It's a static parameter. You cannot change it. And so people pull their hair out about, what if I get the number of shards wrong when I create the index? And especially for logging analytics, I don't know if I'm going to be indexing 1 billion or 2 billion today. And the shard count matters. So the workaround here is actually pretty genius. It is to create an index for every day or every hour, because you can have as many indexes as you want. If you get the number of shards wrong today, change it tomorrow. It doesn't really matter. And then the next thing is, well, if I'm creating an index every day, how do I query 30 indexes if I want to do a query for the last 30 days of something? You create an index alias called last 30 days, you point it to all 30 indexes, and then the API just grabs that one index. So really, really simple, really powerful. Index templates is something that we've added. So if you have a special type of document that you're going to be indexing all the time and you want it to be indexed a certain way, an index template is your friend. And then there's a monitoring API. I mentioned that, and I'll show that in action with Marvel. So any questions before I go into yeah, go ahead.
Security.
Good question. So today, if you want to secure Elasticsearch, you need to put a proxy in front of it, like an Nginx or Apache. And you can put it, basically you'd put a proxy here and you'd intercept the requests and do all your authentication there. But we are coming out with a security plugin in the next few weeks. It's going to be in beta for a while, and that will be part of the commercial subscription. And I can't really say anything other than that until it comes out because it's commercial. Yeah, so it will be released. And it's just going to be a plugin. It's going to give you an ACL for each index, and it will integrate with LDAP and Active Directory. Yeah.
So if I want a security, can I do all the security on the Nginx, for example? Can I use HTTPS within
That's part of the security plugin, is HTTPS. If you want to do it on your own, there's a plugin out there that you can use. I think it makes Elasticsearch run inside of Jetty or Tomcat, and then you can use its certificate handling. Yeah. And then another thing that people have been doing is they'll add security here in their application. Use Spring Security or whatever you want in there, and they'll secure it there because and then they'll, use things like pomegranate security style to lock down Elasticsearch. Security through obscurity works too, but it's probably a bad idea. Yeah. So one thing I wanted to show you guys before I forget, I'm going to show you a demo now that is actually available for you to download if you want. So one of the guys that works for us, Peter Kim, he lives in New York. He found this data set called the New York City Vision Zero project. And it's about people getting killed or injured in accidents in New York. And they track this stuff. They've been tracking it for a couple of years to figure out why people are getting hurt and how to fix intersections and things like that. They offered up all the data for free on their website. And we took it, downloaded it, put it into Elasticsearch, and created a demo that you can go and download yourself. So there's a GitHub repo. It's just in GitHub/Elasticsearch/demo. And if you clone this repo, you need Vagrant and VirtualBox installed. But all you would do is clone this repo, and then in here, go into that web or that folder and type Vagrant up. And what you'll get will look like this. Let me see if I can, so one thing I hate about the Mac still, Microsoft got this right. When I say maximize, maximize. All right. So this is the Kibana UI for the New York City data set. So before I do anything else, I'm going to show you what these documents look like. So the data that we get looks like this. Here's the original data. It's a CSV file. And we parsed it with Logstash and then turn it into this. So it knows there's a timestamp there, the host, that's mine. For this one, the borough is null. That's a bad record. Let me see if there's another one in here. Oh, that borough's null too. Oh, whatever. I'll show you the real data anyway. So, all this stuff will be populated. It'll have where the accident happened, the street name and the cross street name, how many people were injured, killed, cyclists killed or injured, motorists killed or injured, and then the contributing factors for the accident, what caused the accident. Now, it turns out that the number one reason for accidents in New York and probably everywhere is unspecified, which means they didn't capture why the accident happened. So again, a data quality issue. You might want to just say, don't show me unspecified. Yeah, it didn't exist. Not all this data is clean. Yeah. So when you get that data, you can build panels like this. And to build this panel, all you have to do is tell it what kind of panel you want to build. There's a bunch of different ones I'll show you guys in a little bit. And then pick which field you want to show. If there's a particular unit you want to put there, you can. And then pick how you want to display it for this one. And then it will show you based on these queries up here that are pinned. And I don't have time to kind of show everything, so I'm just skipping over some stuff. And then this shows you of these types of accidents, slippery, distraction, inattention, failure to yield, how many people were killed, how many people were injured, pedestrians, motorists, and cyclists. And then down here, all of this data over time is laid on a histogram. So it shows you, based on the colors, here's all the slippery accidents, here's all the distracted driving accidents, here's all the inattention ones, and the purple ones are the failure to yield. So do you guys see anything interesting right away on that histogram? There's some spikes right there. And if you mouse over these spikes, it will show you what it is. So that's on that day, which is January 20th of this year, there were 183 slippery pavement accidents. And if you Google that day in New York, you'll find out that there was a storm the night before. And the cool thing about this is I can zoom in and just look at that data. So now I can see very clearly that the snow happened here. Oh, someone lost consciousness. You can, yeah. One of the things I've been wanting to do is grab some of that weather data and put it in here. And then I was going to show like when the temperature drops below freezing or something like that, and then precipitation is over a certain thing. Snow. That's awesome. I'm going to use that one. Oh my goodness, that's so funny. How many broken hips at the local hospital? Oh, that's so bad. All right. So there was a snowstorm here, and if you notice, like snow doesn't just disappear in New York. It kind of trails off, right? So do the accidents. And then all of a sudden in February there was that nor'easter in New York this year, another big storm. So more accidents.
Yeah, but in between there was a lot of sales of non-stick soled shoes.
And rubber boots and salt. Yeah, exactly. And you could even overlay tweets in here and like show the top terms from the tweets, like top hashtags. And I'd bet you'd see a lot of stuff about snowpocalypse and things like that. Yeah. So when I did that, I just zoomed in on this data. I can zoom in however far I want in here, and it's just going to keep zooming in. And what it's doing is it's creating filters. So there's a difference in Elasticsearch between a query and a filter. And this is something important to know as you start to grow. And a lot of people will just start writing queries, and that's all they'll do. But what we say at Elasticsearch is filter when you can, query when you must. Because queries are expensive. No matter what you do them in, they will probably always be expensive. And what filters do is they say, narrow down the data set that I'm going to query by these parameters. So what we're doing is we're saying, narrow down the query that I'm going to execute, which are these things, by these parameters, which is saying only look from this timestamp to this timestamp. It makes the query lightning fast. And filters are stored as bit sets in Elasticsearch, which means they're cached. So you can cache filters all day long, and they merge in milliseconds or microseconds. The shard. They're cached at a shard level. And Elasticsearch 1.4, which came out yesterday, there's now a query cache too. Yeah, so it's only going to get faster.
So question regarding it. So you're saying, so if I define my filter and I guess I run it the first time, then the results of like every row or something that passes the filter essentially gets added to some other place in Elasticsearch in the index?
It's a bit set under the covers, a Java bit set.
Okay.
And so I don't know if I can explain this all the way. So it's basically zeros and ones under the covers, right? And every single time that you do a filter, it's creating a filter cache inside of Elasticsearch. And they're basically additive, I think is the right way to say it. So if I do a filter on show me all the data from January, and then I do another filter on show me all the data from February, and then I do a query or another filter to say show me from January to the end of February, that will be served out of both of those caches. Because it's going to take the 2-bit sets of zeros and ones, and it's going to do bitwise operations on them and merge them, and that takes like no time at all in any programming language because the processor is optimized for those kinds of operations. So it's lightning fast.
But these bit representations must have references then to the original document. Because
Yes.
you need to
Yeah.
pull
It's
those
a 1 or
out.
0. Did it show up in the document or not?
Okay.
That's all it is. And then it knows what to return. Yeah. And there's going to be a query cache in 1.4. So if you try out 1.4, there's a query cache in there.
Trying to think of what you might use, set depth and slips and injuries and that kind of stuff. But would it be butterfly catches? You see what I'm saying?
No.
So it's really negative. We use depth in a demo.
I know.
People don't
I know.
seem happy.
So this, yeah, the demo was created by a guy in Germany that works for me, and he put death. I said maybe just say killed or no longer with us. Yeah.
It really doesn't matter.
Yeah.
You
I know.
should see
I know.
somebody like a Disney movie. How many kids saw a Disney movie?
We do have a movie data set. That one's fun too, but it always gets morbid when people start talking about, well, show me all the movies that don't have the term XXX or something like that. Yeah, it always goes there.
One more question regarding the filters. So
Yes.
when I add new documents, do those bit sets get updated then? Or do
It'll
they-
get added to when you do a new filter that includes those. It'll just add to the existing one.
So sorry, if I define my filter, I add a new document. When does that document get added to that bit set or not? Or...
Real time next time you execute the filter.
Okay, all right.
Yeah.
Okay.
It'll just happen. You don't have to worry about it. Yeah. Oh, this is it's Leaflet. It's from Leaflet from MapQuest. Yeah. So if you do use there's a 2 map panels in Kibana. In Kibana 3, there's one called Map and there's one called Better Map. This is Better Map. Let's name that because it's a better map. But they serve different purposes. They serve different purposes. In Kibana 4, I'm not sure what we're going to use for mapping yet. Yeah. But so here's an interesting thing. Like, let's say I just want to see accidents in Manhattan. When I click that, it will actually update the map to just show me accidents in Manhattan. So now I can see, oh, there's 117 there. Unfortunately, right now it doesn't. If I click on that, it won't filter everything else out. But what I can do is say, okay, it looks like Broadway and Manhattan is where most accidents happen. So I can click on Broadway. And now you see all these different accidents on Broadway. But I also want to see what cross street, like where does Broadway intersect with another dangerous street? And I don't have a cross street visualization. So what I can do is go in here and say, here's the field name for cross street. And I want to add a visualization for that. So I'm going to go click plus. And I'm going to go terms. Here's all the panels I was telling you about. There's column, goal, histogram, a bunch. And then let's call it cross street. And then put the field name in there. It will autocomplete for you. The length, however long, however many cross streets you want to have, 10's a good default. And then how you want to order them. You can order them by the number, by the term, so alphabetical, and you can verse those. And then you can say, what's that, sorry? It doesn't know that that's a geo, that this is a geo thing yet. You kind of have to determine that on your own. But if that was indexed, you could do it. And then you can pick bar, pie, or table for this particular visualization. I'm going to do this one as a pie chart. And then I can actually show missing another, so it will show you how long the tail is on stuff, which is really important. And then hit save. And now when I scroll back down, now I have this, and other is huge because Broadway's a really long street. So if I don't want to see that, I can go back in here and say, don't show me missing, don't show me other. Oh, and make it a donut, just for fun. And now I have Spring Street is where most, so Spring and Broadway is where most accidents happen. And when I click on that, it's going to filter everything down, show me the intersection, and then when I click on that, it's going to give me all these, so I can start to look. Driver inattention, distraction. So if I scroll back up, you'll also see the biggest contributing factor on that intersection is distracted driving, which happens a lot. But the way that New York City uses this data, and I doubt they got to it this fast, was they use this to actually implement public works projects to fix streets. And if you go to the New York City Vision Zero website, you'll see like overlays of intersections and what they're going to look like to fix confusion. Yeah, it's pretty interesting. All right, so that's that one. Now what I'm going to do is kill that demo. So vagrant halt. And I have another 2 that I want to show you guys just real quick. So I'm going to start Elasticsearch here. It's going to start up. So this is running on my Mac, not on a virtual machine, so it'll be a little faster. And then I'm going to go over to this one. Let me refresh this. Let me go into Logstash search. Oh, it's recovering the indices right now. Let me give it a sec. Yeah, it's recovering them. Do a refresh.
Does Kibana run then in the same process as Elasticsearch?
So Kibana right now is just an HTML5 application. The new version, since it's not out yet, I don't actually know if it's going to be a web application or another HTML5 app. I think eventually it will be a web app run in the Elasticsearch process. Yeah. But still, Kibana will just be a HTML5 app, but it's going to have some server-side components to make it faster. So this is a data set that is from Jordan Sissel. He's one of our engineers that created Logstash. It's from his blog. And basically, let me go to the other one. He gave me a bunch of his log files, and I indexed them into Elasticsearch just to have some fun and see what was there. And I did some searches, but right now it's just showing every event. So it's saying, show me every event over time. And he gave me a few days worth of data. And right instantly, anything, any hit to Apache, because it's all running on Apache. So right away, you can see the most popular requested resource is this jar file. It happens to be an older version of Logstash. It was requested 1,200 times in this time span. And you can see real quick that there's a spike in traffic here. So I'll show you guys that in a sec. You can see all the response codes, where all the queries are coming from or the requests are coming from, Indonesia, US, the top IP addresses. Right away, there's a suspect here, one IP address making 2,599 requests. Interesting. So this thing is really interactive. If I wanted to say, show me where that IP address is, I can click this and it will show me exactly where that IP address is coming from. Looks like it's Indonesia. Inside of Logstash, you do the GeoIP enrichment. Yeah, so it's on the way in. And look, there's the spike. So right away, there was a spike in data, and I was able to just say, show me this IP address. It shows me the spike, and it shows me all the requested resources. And if you look at this, look at the tail on that spike. Like that's basically requesting every page one time. So it means it's probably a search engine crawling my website, or it's someone trying to hack. If you look at this thing, look at this. It's looking for a password file. Interesting. Yeah. So right away, probably not a great thing. I might want to just blacklist that IP address right away. And if you know, there's a lot of hackers that use the same URL schemes over and over again. I don't know if on the black internet there's or black market or whatever, there's a set of like resources that you can request if you're a hacker. Like always request these things on Apache. You can basically put those in Logstash or put them in the searches and build a dashboard just for that stuff. We will eventually. We don't yet. There's a Logstash dashboard that comes out of the box by default, but it's still pretty basic. We're moving towards, with Kibana 4, we're moving towards having apps that you can actually just say, I want the logging analytics app for the lamp stack maybe, right? And it just gives you the dashboards for that. But right now you have to build it. But I mean, you guys saw me at a panel. It takes minutes to build these things. So if I want to get rid of that, I just X that out. Now, it's interesting to see this, but it's not that interesting. So another thing you can do is what's called top in queries. And this will take any field and show you the top X resources mapped on the histogram. So what I told it to do now is say, take the top 5 things that are requested on my website and overlay them on the histogram. So I can see this spike looks like it's one resource. Instantly, I can see that this is the jar file. That was the spike for that period of time that was requested. And if I wanted to, I could change this query. So there's Lucene, which is the default. There's regex. You can put a regex in there, and then there's top in. So I could say, show me the top 5 requested resources, show me the top 10, and then it's going to requery, refilter, load all that into memory, and then show me the top 10. And I may not have started this with enough memory. We'll see. There it goes. So the interesting thing is, as soon as I change that, there's 3 spikes. I didn't see that before, but all of a sudden I see it now. And what is that? It's a PDF. And if you're not in the know, you might wonder why there's a presentation folder with a FPM scale 12x PDF. Just so happens that this is at the time when Jordan was doing a conference and a bunch of people were asking for this. So it could be that someone tweeted it out and a bunch of people grabbed it. Someone retweeted it, a bunch of people grabbed it. I honestly don't know how these spikes appear, why they do, but it's just something that surfaced right away. Pretty interesting. And you can do this for anything. So if you don't care about resources and you want to see what's the relationship between like 500 errors, 404s, whatever, you could change this to be their response code. So let's do response.raw. Actually, I think it's just response is fine. And then I just want to see the top 5. And I'm going to hit enter. And now what's going to happen is it's going to show me, based on the response codes, it's going to overlay them. And I could even stack this if I wanted to. So I could say stack it. And now I see 200, 404, 206, 304, 301. So you can slice and dice this however you want. It's really up to you.
And it's now 50 gig on disk.
The size of this one? No, it's not that big.
At the bottom it said,
Oh, that's based on the number of bytes that were served from the Apache web server.
Okay.
Yeah, so that's 50 gigs. Okay. Yeah. And it will lay it out. So of that, here's the successful total. So 43 gig of that was for 200s, and then 950 kilobytes was from 404s. 206s were 13.54 gigs. Yeah. And then if I say, I just want to see Canada, I'm serving 8.1 megs to Canada. Yeah.
So, but just to get a feeling, like, because you did these interactive queries and it took like a couple of seconds, like 1-2 seconds sometimes, like, so what's the size of the data on this right now?
Oh, I think it's like 280 megs maybe.
Okay, all right.
Yeah. And I'm just running on my laptop with like a 256 meg heap. So it's not even a gig heap.
I see.
Yeah. So Elasticsearch is memory intensive, but it uses file system cache because of Lucene. So there's this new feature that we introduced in 1.0, and we're making advancements on it right now called doc values, which basically does a bunch of pre-computation on the fields you're indexing, and it makes it so it uses much less JVM heap, and it transitions that all to the file system cache. So one of the best practices is to never give Elasticsearch more than like 32 gigs of heap space, because then you get into 64-bit pointer world. The other one is you should only ever give it up to half of your memory, up to 32 gig. So if you have a machine with 128 gigs, you could run 2 nodes on that thing. Make sure they're not sharing disks, but yeah. So the other thing I wanted to show you guys was just some fun. So any data that you find online, it's fun to just bring it in here and play around with it. This is crunchbase data, which shows all the funding events for companies. So you could say, it looks like the US gets the lion's share of funding. It's at 15% software, biotech. Let's see biotech. So I click on biotech. Now everything's filtered by biotech. You can see funding rounds. Most people just get 1, 2, 3, 4. It goes down pretty quick. Down here I have the table that shows the data. Let's see, company name, who got the most funding rounds in biotech. It looks like Avir, is that right? Avir, and then Covenant Surgical Partners, whoever they are, got 14 rounds. If you say, just show me, I just want to see people that went over 10, you could say, show me funding rounds, colon, square bracket, 10 to, and the case is important, bracket. Now it's going to show you just biotech companies that had more than 10 or more funding rounds. And this list is much smaller now.
Is that Lucene syntax?
Yep, that's Lucene query syntax. Yeah. And that's US, sorry. So if I wanted to see total, I could say get rid of this thing. Or no, sorry. That's just biotech that just so happens to be in the US. Interesting.
Can you export or save these or print them?
So right now you can save, and there's an advanced feature, so you can export schema, which is JSON. You can save this thing as home. In the new version, we're going to allow CSV export.
So let's
Oh, save it as your home's dashboard. So when you go to Kibana, it's your home dashboard. Yeah. Otherwise, you get to the home screen, which is this. Yeah, that's all. You can name them whatever you want, and then you just click on here to get to them. Yeah.
And you said it's fun to bring data in.
Alerting is a roadmap item.
You said it's fun to bring data in. So what would you suggest as the best way or easiest way to get data in?
So the very first thing I would do is go to that GitHub demo repo and try that out.
Right.
And there's a lot of instructions in there and a lot of examples of how we got the data in. But what I do is I actually keep a bookmark of data sources. So I have bookmarked a massive amount of data sources just to go find and try and play with. One of my favorite ones after the Super Bowl was the NFL data set that showed why the Seahawks are better than the 49ers. I use that one in the Bay all the time. They love it. They totally love it. But you can see, like, show me the player that fumbles the most. Show me the quarterback that throws the most interceptions. Which defense allows the least yards per rushing or something like that. Really fun. And there's a blog on the ElasticSearch website where one of our designers, Shelby Sturgis, he wrote a blog post about the NFL data set. And the link to the data set's on there. So just do a search for ElasticSearch NFL and you'll find it. But
in general, you probably have to do some data janitor work in order to.
You'll have to do some processing, like use CSV or use something that has it already in JSON is good. Like the Stack Overflow data you can get, that comes in XML, and there's a little parser out there online you can use to do that one. There's a bunch. So another fun one is the government websites. So data.gov and data.co.uk, I think, .gov or something. They have a lot of data on there. Those are a lot of fun. I actually was doing a demo once to a company in London, and it was the day that our government shut down. And I went to data.gov in my browser, and it came up with a 404 or whatever. I was like, oh, that's right, our government's offline today. And then I went to theirs, and it worked just fine. It was actually really funny. Yeah. All right. Any questions? Yeah, so Logstash has a CSV input, or sorry, a CSV codec, basically, or filter, sorry. So if you go to logstash.net, eventually this will be integrated with our website. But here's the list of all the inputs, codecs, filters, and outputs. It's huge. And this is just from Logstash. I mean, you can use whatever you want. I used to use Groovy when I first started because I was comfortable with Groovy, but now I'm starting to use Logstash for a lot. And I use so what I do is I write a file input. Actually, let me just show you guys an example here. Go development, get Elasticsearch, demos, New York City. Here's an example file. All right, so this is an example Logstash config that we use to index the New York City traffic data from a CSV. Turns out they actually had a JSON on their website, but it was crap. So we use the CSV. What does that sound? All right, well, maybe it's some sort of refrigerant thing. So input is standard in because we just pipe the CSV into Logstash. And then the filter is CSV, and you list all the column names that you're going to be dealing with up there. Very simple. And then you can do conditional logic. So we wanted to get the longitude and latitude field put into our own little thing, so we did that. And then we're converting some stuff, removing some fields. And then we're adding fields. And then down here, in the CSV file, contributing factors, and this is really common, is actually contributing factor 1, 2, 3, 4, 5. And there were multiple contributing factors for accidents. So what we did was we put all of those into one comma-separated field. And that's what this is about, merging. And then we do a date match to get the timestamp right. And then down here at the bottom is how you send it to Elasticsearch. So this is a pretty big one because there's a lot of conditional logic to clean up that CSV file on the way in. But for Apache, it can be just a few lines.
So this is a Logstash config?
This is a Logstash config, yeah. So when you start Logstash, you tell it which config file to use. It will load it and then do whatever you tell it. And it's going to start at the top by saying, where am I getting my data? How am I filtering it? And then where am I sending it?
Is it based on some other language?
It's all Ruby. Yeah. Yeah, you can actually do Ruby code in a Logstash config if you want to.
Okay.
Yeah.
Is it only Ruby or can you use Python?
else?
Only Ruby, yeah. In Elasticsearch, you can do scripting in there as well, which we don't have time to talk about, but you can use Groovy. Groovy is the default scripting language in Elasticsearch because you can do scripted scores and things like that. Pretty powerful.
Couple quick questions.
Yeah.
You mentioned about like uploading documents for indexing and stuff there. Do you actually allow large logs, upload to large compressed logs, like different compression formats like VZIP or something?
You have to decompress it and parse it line by line. Yeah.
The other thing you mentioned about was geo supported instead of Elasticsearch. Are there rules in there or queries in there I can put, like, for instance, you showed the accident stuff, that within, given a latitude and longitude coordinates, like within a mile radius, show me all the accidents?
Yeah. So let me actually show you this on the Elasticsearch website. So if you go to Elasticsearch, actually, I think I can just go to .com. Let me see. So there's by the way, a couple of developers at Elasticsearch have been writing a book. It's called Elasticsearch: The Definitive Guide. It's available online. It's also for print, but you can read the entire book online, and it's just about ready for publishing. But we've been writing it all along. So if you read it 2 months ago, you'd find to-dos in the documentation. But we're trying to be as open as possible. So if I go into here and I do a search for geo, then I have all these different geo aggregations and queries. So you can do polygons. I mean, you name it. There's a massive amount in here. Let me go back. So this is aggregations. So this is a good example of all the aggregations you can do. So when you think about analytics, these are all the types of dashboards. Think about dashboards you can build. You can do percentiles, like show me the 95th percentile of something. You can do value counts, extended stats, cardinality, how unique is my data, geo bounds. Top hits is really powerful. So you could say, show me the top requested resources and then group them by something else. So you could say, show me the top requested resources every 5 minutes for the last hour. And it'll show you. This is how I found out there was a slippery accidents thing in New York, is because I said, show me the top contributing factors by day for the month of January. And I just started looking through the list, and all of a sudden slippery pavement popped up. It's like, oh, that's interesting. That's how I got to that demo. There's a filter missing, nested. There's a bunch. Let me go into queries real quick. Oh, and there's a really powerful one called significant terms. One thing that you guys, I would highly recommend is do a Google search for uncommonly common with Elasticsearch. And Mark Harwood, the developer of the significant terms aggregation, talks about how to use it. It is amazingly powerful. People are using it for fraud detection, finding like just kind of outlier things. It's amazing. Yeah. If we have more time or later, I'll describe it for anyone that's interested.
I've been watching you guys for at least 2 years, and you've come so far in such a short period of time. It's really fucking amazing.
It's pretty amazing. I've only been at the company for a year, and it's amazing how far we've come. They changed the documentation. Sorry. I'm trying to find it. But it lists out all the different geo searches you can do. There's a bounding box. Oh, there it is, query DSL. Queries. Here we go. All right, so there's match, multi-match, booleans, boosting, common terms, dismax, fuzzy searches, geo shapes. I mentioned parent-child relationships. You can do has parent, has child. More like this, regular expressions.
Are you trying to tackle the sentiment analysis?
People are using Elasticsearch for sentiment analysis. We don't have anything built in today that will do that for you. Significant terms is a step in that direction. Yeah. Yeah. Anyway, there's a bunch in here. I just don't know where they moved to. Yeah. But you can do polygons. You can do distance. So you can say, show me everything inside this bounding box, show me everything outside this box, things like that.
So it sounds like, for instance, like Solar is also based on the scene, but it looks like Elasticsearch has got a better integration with Logstash and, Kibana dashboard stuff.
Yeah.
It provides better user experience, overall user experience, fair to say.
Yeah, that's exactly what people tell me. I mean, people are moving from Solar to Elasticsearch for a number of reasons, but one of them is developer productivity. And what a lot of people don't know is that Elasticsearch now makes, in any given month, between 45% and 75% of the Lucene commits.
Steve, thank you very much.
Yeah,
Great
thank
job.
you guys.